This video provides a standard operating procedure for migrating custom GPTs to Claude Projects, ensuring a zero-loss data transfer. The process involves moving the custom GPT data packet from the source engine to the destination workspace. The migration triage matrix helps select the right path. We will focus on the custom GPT migration method, which uses logic translation to preserve specialized tools and knowledge bases. The migration is a structural sequence. It involves copying the system prompt and downloading reference files from the custom GPT, then creating a new Claude project to paste the instructions and upload the files. Phase 1 is project initialization. Navigate to the project section on the left-hand side of the Claude interface. Click New Project to initialize a blank workspace. The project description is a routing magnet for the context engine. Write a highly detailed description for your new project. This allows Claude to intelligently trigger the specific project's knowledge, even when operating in the main interface. Phase 2. Locating the source. Open ChatGPT in a separate window. Locate your custom GPT and click Edit GPT to access the backend configuration settings. Phase 2 continues with extracting the core logic. Locate the instructions or system prompt section and copy the entire text block to your clipboard. Next, inject the core logic. Return to your Claude project window, paste the copied system prompt into the instructions field, and click Save to lock in the foundational logic. Phase 3. Extracting knowledge files. Return to the ChatGPT Edit GPT view. Identify and download your uploaded knowledge files, such as CSV spreadsheets or reference documents, directly to your local device. Now, populate the knowledge. Locate the Files area in your Claude project. Click Upload from Device, and select the recently downloaded reference files to populate the knowledge base. Be aware of a technical constraint, the 31 megabytes bottleneck. Claude projects impose an absolute file size limit of 31 megabytes. Uploading deep historical archives directly will cause a hard failure. The bypass for massive historical datasets is splitting via Claude Cowork. This automated parsing process breaks down large files into smaller chunks that can be integrated into your Claude project. Finally, complete the QA and verification checklist. Confirm zero data loss through a functional test. Verify instruction integrity, context awareness, and data parsing by asking the project a specific question. An alternate path is native memory import, a rapid loop for high-efficiency persona syncing. This executes a loop to grant immediate, platform-wide context without manual data cleaning. The migration is complete with zero data loss. Your logic, context, and reference architectures are successfully transitioned. Initiate your first functional workflow query within the new project environment.